Welcome! In this lesson, you will learn how to create a working model using functional mockup interface and walk through the steps required. The test case rc.fmu provided in the tutorial FMU subdirectory of SimCenter ImSim is an FMU for model exchange of a very simple linear first-order RC electrical system. Its circuit schematics and equations are represented in the figure below. The supplied voltage U is an input of the model, whereas the voltage Y across the capacitor is an output. There are two parameters called R and C associated to the corresponding elements of the circuit. The model has only one state variable called Q, which is the electrical charge in the capacitor. There is also one internal variable called I, the current flowing through the circuit. It's easier to place the FMU in the directory where the associated SimCenter ImSim import submodel is to be created. Here we copy the rc.fmu file to the path cdisk imtest. Pull down the interface's FMU import assistant command. This opens the first step of the FMU import assistant. Choosing the FMU to import. Click the expansion button next to the FMU field to select the rc.fmu file. In the submodel storage directory field, enter the path to the directory where the import submodel is to be created. Here we input cdisk imtest and check the submodel name checkbox to let the assistant automatically choose a name for the submodel and click the Next button. Step 2. The second step of the FM unit import assistant deals with the import setting. At this step, the compiler used to build the submodel has to be chosen according to the compiler selected in SimCenter ImSim to build the model which uses the import submodel. The two compilers have to be chosen consistently. Here we keep the default setting. You can safely ignore the preferred mode for mixed type FM units button, since it's only relevant to mixed type FM units. Click the Generate button to proceed to the next step of the assistant. Step 3. This is the last step of assistant. Click the Finish button. At this step, a new SimCenter ImSim library node is created in the current directory, containing an import submodel called MEIMPRC, made of a SPE description file and a CSource file, which is automatically compiled using the MCC release script. The library contains an icon called RC, which was automatically created by the import tool. This is a default icon for the FMU component, having one input signal type variable, the supplied voltage U, and one output signal type variable, the voltage Y. A subdirectory with the same name as the FMU, here RC, is also created in the current directory, containing the unpacked FMU zip file. After clicking the Finish button, the path to the new library node is automatically added to the catalog path list of the SimCenter ImSim. Step 4. Drag and drop two instances of the icon onto the sketch and provide a step signal source and a sine wave signal source as input to the two components respectively. Connect with two signal sinks. A test SimCenter ImSim model is created in the sketch mode. As of this step, the documentation extracted from the FMU can be displayed in Help by right-clicking one of the two icons and choosing Help. We can see the description, parameters, and variables of RC component. Step 5. In submodel mode, the submodel is associated with the two icons. Double-click on the icon and the details are shown in the dialog. Step 6. In parameter mode, the parameters of the two instances are displayed, and their value can be changed. You will notice that two additional parameters called startQ and startU are available. These parameters correspond to the start values of the variable q and u, as defined in the XML model description file. Two other parameters are also automatically added to the submodel. Enable logging is an enumeration, taking the values yes or no. If set to yes, the logging messages from the FMU are reported in the simulation log window. FMU location is the path to the unpackaged FMU. It is the path to the directory in which the import tool previously extracted the content of FMU. Step 7. Shift to Simulation tab, and after the compilation is finished, run the simulation. The transient simulation is then started, and the result variables are available in the variable list shown in the variable window. The results can be plotted. In addition to the 4 variables declared by the FMU model description, a variable called x0 is automatically introduced. It represents the state variable of the original model. Although this is an alliance of the q variable declared in the model description, the FMI for Model Exchange 1.0 specification defines anonymous state variables, which are only known by their value reference. That's why the import tool automatically generates as many state variables as the number of continuous states declared in the XML model description file.